All right, as I mentioned, this is going to be a really short ed puzzle. We've done most of the introduction and discovery the last ed puzzle and in class, so today is just a little bit more exploration. So just a quick review, what does it mean to actually be a function? I'm going to draw a couple examples for us. So we have a linear function, a parabola, a sleeping parabola, and a circle. Now, to be a function, that means there is only one output per input. So these two on the left, linear and parabolas, these two are functions. They do meet that definition of one output per input. Sleeping parabola and circle, however, are not functions. They've got more than one output at a single input. And then the way that we can visually test that is called the vertical line test. If I draw or if I visualize a vertical line going through any point of my function, and there's only one intersection, that means it's a function, versus over here where there are two intersections, that tells us it is not a function. So for number 55, you're going to try and find the inverse equations of the parent equations below and put it into y = form if you can. Then you're going to graph both the original and the inverse on the same set of axes. Now for y = b to the x, this is what you explored today in class. So your investigation for this one is already done. So just imagining that b is a 3, that part's already done if you did your classwork today. You are going to do this on your own, but I want you to practice both the equations and the graph of all of our parent functions that we've done so far. All right, pause this if you need to. But here are my first 4 answers where the black is the original and the green is the inverse. And my next 4, and I apologize, I forgot to do my inverse graph for the other part of the hyperbola. Whoops. And now that you're done with that, we've got 2 questions to answer about all of your functions. The first one asks, are any parent functions their own inverse? So what that means is the inverse looks the exact same as the parent function, as if nothing had changed at all. There are 3 of these, and I want to identify the parent functions where this happens. Our first one is y = x. That is our line of symmetry for all inverses, so it is going to land on top of itself. Our second one is y = 1 over x, which we call our hyperbola. And our circle, even though it's not a function, it does become its own inverse. And I kind of just answered one of the problems for part C. So I'm looking for the inverses that aren't functions, even if the parent function is. So my inverse of y = x squared is that sleeping parabola, which we know is not a function. X squared plus y squared = 1. Our circle we already know is not a function. And our last one is the absolute value. So y = absolute value of x. The inverse looks very similar to our sleeping parabola. It's basically just a sleeping absolute value. And to wrap everything up, we have quite a few ways of finding the inverses. We can think about it both algebraically using the equations and graphically. So with the equation, we've got our 2 methods. We have the flip it and reverse it, which is when you write out the bullet points, you flip the operations, and then you reverse the order in order to write the inverse equation. Our other method is when I switch x and y, just write in that original equation, and then I rewrite it so that the y is alone, which then gives us the inverse equation. On a graph, if we plot our original points, and then if we reflect that across the y equals x, which is our line of symmetry, that will give us our new points. And then another way to think about that is changing any points in the original xy into the point yx for the inverse.